The definition of molarity is moles of solute divided by the liters of solution. And what I like to remember is this little equation here. We use capital M to symbolize the molarity, and M equals moles over liters. So normally we have to make sure that we have the right units. We want the solute amount in moles and the total solution amount in liters. And remember that the solution is made up of the solute plus the solvent. So we always measure the volume of solution after the solution is made. You don't just measure the amount of solvent that's added. So let's take a look at a typical problem. Number 1 here says 3.47 grams of iron sulfate, and that is iron 3 sulfate, solid is added to enough water liquid to make 250 milliliters of solution. So notice the wording there. It says added to enough water to make 250 milliliters of solution. We don't say added to 250 milliliters of water because we measure the solution after it's made. So what is the molarity of this solution? So the way we want to handle a problem like this is to convert the amount of solute from grams to moles. So we'll need the molar mass of iron 3 sulfate. And then we want to convert milliliters of solution into liters, and then we divide the moles by the liters. So this is the most straightforward version of a molarity problem. So let's first take the amount of solute and convert that to liters. 3.47 grams of iron 3 sulfate. Iron 3 sulfate has a molar mass of 399.89 grams, so let's divide by the molar mass. 399.89 grams is 1 mole of iron sulfate. Okay, when you do that in your calculator, you get 0.008677 moles. And there's no reason to round yet. So you don't want to round until you get to the final answer. And now we just want to make sure that our milliliters get converted to liters. And you can usually do this in your head just by moving the decimal place over 3 to the left. But I'll show it explicitly here. Divide by 1,000 milliliters. Make sure you use your unit conversion method, and you get 0.25 liters. So the molarity is moles divided by liters. So we've got our number of moles of solute. Let's divide by 0.25 liters. And this solution has a molarity of 0.035 molar in iron 3 sulfate. And that's how we would say this. We would say that we have a 0.35 molar aqueous solution of iron sulfate. The second problem here says how many grams of potassium nitrate is needed to make 500 milliliters of 1.5 molar potassium nitrate aqueous solution. So this is a very practical problem, and this is asking us, how many grams of solid would we need to weigh out in the lab to make, this much 500 milliliters of this concentration, 1.5 molar potassium nitrate solution. So in this case, we're going to use the equation to solve for the number of moles. So remember, if you got this equation memorized, you'll be able to figure out any of these molarity problems by thinking of this equation. And anytime you see the capital M, you can write it as moles over liters. So let's solve for moles in this equation. The number of moles is the molarity times the volume, right? Because if you work out the units, molarity is moles over liters, volume is in liters, volume cancels out, and you get the number of moles. So this is always the way that I tackle these equations. If you've got a volume and a molarity, multiply them together, make sure you convert to liters first. So the number of moles of potassium nitrate is the molarity times the volume. So 1.5, and anytime you see this capital M, you can write it as moles over liters. And then let's make sure we put 500 milliliters in liters, move the decimal place over 3 to the left, and we've got 0.75 moles of potassium nitrate. That's the number of moles of potassium nitrate that it's going to take to make this volume of that concentration of solution. Okay, so the next step is to convert that to grams. And for that, we're going to need the molar mass. So you'll have to calculate the molar mass of potassium nitrate. This time we're going to multiply by the molar mass. Moles are on the bottom. Those are going to cancel out. 1 mole of potassium nitrate is 101.11 grams. So we multiply those together, we get 75.8 grams of potassium nitrate. That's what you would weigh out in the lab if you were going to make this solution.